Welcome to Apex Insights, our educational series about the best practices for water safety and water management programs. Today, we will focus on ASHRAE 514 point-of-use filtration solutions. We will discuss what ASHRAE 514 is, where does it apply, what types of point-of-use filtration are required for healthcare facilities, and how to leverage point-of-use filtration to safeguard your patient safety and your operations. First, what is ASHRAE 514 and where does it apply? ASHRAE 514 is a newer standard released in 2023 that builds on ASHRAE 188. While ASHRAE 188 focuses primarily on Legionella and establishes the framework for water management programs, ASHRAE 514 expands that scope to address all waterborne hazards using a broader, risk-based approach. This includes physical risks like temperature, chemical risks such as disinfectants and metals, and microbiological risks like Pseudomonas and Mycobacterium. ASHRAE 514 applies directly to healthcare facilities, including hospitals, ambulatory surgery centers, and long-term care facilities. It also provides more detailed guidance on control measures, including the use of point-of-use filtration in high-risk areas and critical devices. ASHRAE 514 says exactly this: water filtered by FDA Class II filters that are tested in accordance with ASTM F838 and validated for total retention, F8383, or by a filter with a class and level of performance based on the designated team's risk assessment, should be supplied to or used in non-steam humidifiers, ice machines, misters, and other items used for patient or resident care as determined by the designated team. There are higher risk areas around the hospital recommended to use filters with the same statement above: burn unit, transplant, ICU, infusion, etc. Certain medical devices like heater coolers, automated endoscope reprocessors, and life support devices are also recommended. Why point-of-use filtration is needed in healthcare facilities? Healthcare facilities rely on municipal water systems that are not designed to deliver sterile water. As water moves through the building, bacteria found in municipal water can amplify, especially at outlets and various devices. Even with facilities that have supplemental disinfection, the risks are still there given what happens throughout the facility's infrastructure. Biofilm builds up in outlets, water stagnates in low-use areas, and medical devices create direct exposure pathways. So even with a solid water management program, risk still exists. Without proper filtration, we commonly see positive Legionella or Pseudomonas results, contaminated ice machines, outbreak concerns in ICU, NICU, or transplant units, and increasing pressure from CMS and accrediting bodies. The reality is, risk exists right where water meets the patient. That's why point-of-use filtration matters. It ensures safe, reliable water exactly where patients interact with it. What are the key applications of point-of-use filters? ASHRAE 514 clearly identifies where point-of-use filtration is most critical, based on risk level, patient vulnerability, and exposure pathways. And in these environments, water quality is tightly controlled. These quality limits, like colony-forming units, or CFUs, and endotoxins, measure the amount of live bacteria, and in some cases bacterial toxins, in the water. Starting with very high-risk areas, this includes ICU, NICU, and burn units. Multiple point-of-use outlets are often required to protect sinks, showers, and patient care areas. Facility water management teams should conduct a risk assessment to establish the appropriate water quality control limits. Next, sterile processing and dialysis. These are also very high-risk applications, where water comes into direct contact with instruments, or even the bloodstream. Here, filtration must go beyond bacteria removal, requiring endotoxin control and highly purified water. Water quality target is less than 10 CFU per milliliter for sterile processing and less than 100 CFU per milliliter for dialysis, with strict endotoxin limits for critical applications. In surgical and critical care environments, devices like endoscope reprocessors, heater coolers, and ECMO systems introduce direct exposure pathways. These require device-specific point-of-use filtration, designed to meet both microbiological and performance standards. Water quality target is near zero bacterial levels, with device-specific performance and sterility requirements. Moving to patient rooms, which are considered high risk. Sinks and showers are common exposure points, especially through inhalation and ingestion. This is where terminal faucet and shower filters play a key role. helping reduce patient exposure right at the point of use. Water quality target is typically less than 500 CFU per milliliters at the outlet. And finally, general areas like corridors and shared spaces. Devices such as ice machines, drinking fountains, and humidifiers can also act as contamination sources. These applications typically use inline or sterilizing grade filters to maintain safe, consistent water quality. Water quality target is low to non-detectable bacterial levels, depending on application and risk level. So why does this matter? Because water can enter the body in multiple ways, through inhalation, ingestion, or direct contact. And in healthcare environments, those exposure pathways can directly impact patient outcomes. That's why these applications often require high-performance filtration at or below 0.22 microns, sterilizing grade water in critical applications, and endotoxin control where applicable. What are the main point-of-use filtration types? Point-of-use filtration is a final barrier installed at the outlet or directly on a device. There are several types: terminal filters for faucets and showers, inline filters for ice machines and drinking water, sterilizing grade filters for dialysis and sterile processing, and device-specific filters for specialized equipment. Think of it as the last line of defense, protecting water at the exact moment it matters most. Point-of-use filtration creates strong ROI for healthcare facilities by closing gaps in water management programs and helping avoid costly operational disruptions. Point-of-use filtration protects patients at the point of exposure, ensures compliance with regulations, reduces citation risks during surveys and unexpected outbreaks. It also protects reliable water quality for critical applications, and point-of-use filtration can often be deployed within 24 hours, helping safeguard your operation and gives you peace of mind. To wrap up, ASHRAE 514 is raising the standard, making it clear that managing risk at the point of use is critical. And point-of-use filtration is one of the fastest, most effective ways to meet that need. At the end of the day, this isn't about filters, it's about protecting your patients, reducing risk, and helping you stay compliant and prepared. Reach out to your Apex team to learn more about how we can help elevate your water safety and patient safety.